Let's have a look at this electric circuit. It says here to find the equivalent resistance and the total current. First thing we do is take an overall view of the circuit itself, see what resistors are in parallel and which ones are in series. And looking at this, I can see that these two are in parallel to each other, and these two are in parallel to each other, and this grouping is in series with each other, going this way. So we'll need to tackle this a little at a time. We could start with this one. They're both in parallel, and find the equivalent resistance, and that equivalent resistance would be placed in here, down the middle. So I'll separate these two into one and put it down the middle. And then take these two, they're both in parallel, find the equivalent resistance of these two, and it would also be, the equivalent one would be down the middle here. Then that would make us, this one and that one would be in series to each other. And then solve the two series ones. So let's do that. Let's look at these two right here. They're parallel, and let's find what the equivalent resistance is for these two that are in parallel. Now when there are two resistors in parallel, we can use this equation here. Makes it simpler. This is if there are 3, 4, 5, 6 resistors in parallel, we need to use this one. But when there are only two of them, we can reduce that to just this simple equation here. So the equivalent resistance is equal to R1 times R2 divided by R1 plus R2. Looking at this one, R equivalent is equal to R1 R2 divided by R1 plus R2. And it doesn't matter how I want to label these. I'll call this one R1 and this one R2. Putting in the numbers, so R1 is 100 ohms times 250 ohms. We'll go like this. And divided by the two of them added together, 100 plus 250. R equivalent for these two is, solving this, 71.4 ohms. And let's do the same for these two. R equivalent is equal to, and in this case they're labeled R3 and R4, so I'll write down R3, R4 divided by R3 plus R4. Putting in the numbers, it's 350 multiplied by 200. Everything divided by the two of them added together. And that R equivalent is equal to 127 ohms. So this one right here, when I take these two and turn it into its equivalent one, it basically goes right down the center here. So that's my R equivalent here. And those two are no longer here. And the same thing applies here, so it would be, that would be my new R equivalent, this one here. And those two are no longer in my circuit. So I can redraw this circuit so it looks like this. And this is 24 volts. And the two resistances here is 71.4 ohms and 127 ohms. Now these two, as you can see, are in series to each other. So let's find the equivalent resistance now in a series, and back to our equations. For a series resistance, just simply add up all the resistors that are in series. So R equivalent for this grouping is equal to R1 plus R2 plus R3. In our case, it's equal to 71.4 ohms plus 127 ohms. And that is 198.4 ohms. Now these two can be replaced by one resistor, this one here. I can redraw this diagram. And this resistance here, this new one, And we'll call this one this here R1, R2, R3, R4. We'll go with R5. Is equal to 198.4 ohms. So this one is the replacement resistance theoretically, for all of these. And this is done strictly for calculations, mathematical calculations. And we do this in order to calculate the current. You want to find the current. So to calculate the current, we need to find what the equivalent resistance is. And back to the original question, is find the equivalent resistance. And we have done that. Here it is. Total equivalent resistance. And now we're asked to find what the current is. It's difficult to find the current in this scenario here, but it's a whole lot easier once you've reduced all the resistors into a single one. So we have this very simple circuit. We have a voltage, a resistance, and a current. So using Ohm's law, V equals IR. And we want to find the current total. Voltage is 24 volts. Current total we want to find, and the resistance is 198.4 ohms. Dividing both sides. Is equal to the total current. Doing that division. And when you divide a voltage by ohms, we have amps. Total current then is equal to 0.121 amps.